So I only got 4 problems. Then we'll do our little math break at home. You can kind of start to work and see what other problems you're doing on your problem set. Okay, so this is just kind of a random problem. Okay, solve it. Great. So the first thing I need to do is, right now there's no, I don't know of any methods I can really do. Technically the left is factored, but if you factor it needs to be equal to 0, so that's a snap sheet. You can help me out. So the first thing you need to focus on is just getting your setup where it needs to be. So in this case, I am going to distribute that left side. I would get 2x squared, and that would be minus 8x plus 1x, which would be minus 7x minus 4 equals 12. Okay, so we're looking a little better just setup wise. And I'm going to set it equal to 0. So if you're kind of going in like, I don't like notice a certain setup, I always kind of set it equal to 0 and go from there. The reason being is, since this is squared, you can't use square roots because you have a middle term. So square roots is out. So let me write the methods. The methods to our madness over here. Can you see that? You can. Okay. The methods are quadratic formula. Works for all quadratics, so that's kind of nice. Sometimes it might be a little annoying to get something into the form you need for a quadratic formula, so depending on the problem, we'll look at that in a minute. We have completing the square. That is the one we had just done most recently before quadratic formula. I don't really feel like completing the square. I'd have to divide everything by 2. I'd end up with fractions. I just don't want to do it. It seems like way too much work. If I see a nice setup, I'll go with it, but nah. Factoring is one way. I don't think that's factorable, so that's not going to help me. If you notice something is factorable, great. We'll see later using the discriminant how to actually tell if something's factorable. And then last but not least is square roots. Okay. So those are the 4 kind of methods that we have in our pocket. If it just says solve, we can pick any of those. For this one, I'm just going with quadratic formula. I looked quick. I don't think it's factorable. Completing the square seems kind of annoying. Square roots isn't going to work because we have an x term. So quadratic formula will work all the time. So that's kind of nice. So let's just start to plug in. So x is going to equal negative b. So b is negative 7. So that would turn positive. Plus or minus. Underneath my square root is b squared minus 4 times a times c. And the whole thing is over 2 times a. So I grab my calculator because let's be honest, I'm not doing any of this in my head. I always simplify under my radical, so let's see what I get. 177, okay. So x is going to equal 7 plus or minus the square root of 177 over 4. I think that's it, right? 177? Wait, is that divisible by 3? It is, but then it's 59, and that's prime. So I think we're good. Yeah, there's no, all of its factors are prime. So we're good. So the main goal of that one is just get if you have like kind of a weird setup or you have to distribute, do that. Get things in standard form equal to 0. If it doesn't lend itself to another setup, quadratic formula is always going to work.
I wanted to ask, in the packet, like I'd get something like that for an answer.
Yeah.
And then I would solve for what x equals either a positive or negative decimal. Do we have to do that?
No, you don't. To tell you the truth, I don't want decimals unless it's a word problem.
Okay.
So word problems have like context. So if it's like time and you said that was a time, that's weird. But no, just for a solving one, just leave it as a simplified radical. And you're good. At home, feel free to always chime in if you need anything. You can type it in the chat. But just as a reminder, quadratic formula, get in standard form equal to 0 and kind of go from there. All right, so let's look at some other things because there were things that popped up I just wanted to show you. So this is another setup. So this one will be set up a little bit different. It's just recognizing when you see this setup what you do. So technically, I could use quadratic formula if I wanted to. If I wanted to use quadratic formula, I'd have to expand that. I'd have to do 2x plus 3 times 2x plus 3. I'd have to distribute it. I'd have to set it equal to 0, and then I'd have my a, b, and c I plug in. It's not going to be the best method for this specific problem. So I'm not going to use quadratic formula. I'll show you which one I'm using. I'm not going to complete the square, because once again, I'd have to distribute everything out. That's a pain. I'm not going to factor it, but I can use square roots. We've seen this. This is actually like the middle step of completing the square, and we did it with square roots. Even before that, if you see you have something, in this case we have a binomial squared, I can just take care of that by taking the square root. So don't do more work than you have to. Don't put it in another form to do something else. If you see this set up, use square roots. The squared cancels. I'm left with 2x plus 3 equals, remember when you do the square root, always plus or minus. This, we can simplify this radical. There's a negative, so I'm going to have an I, and we know the square root of 25 is 5, so it'll be 5i. So it was way easier than doing just even the setup of the other one. Our main goal is to solve for x, so subtract 3. 2x equals, I'm going to write that as negative 3 plus or minus 5i, because the plus or minus kind of separates them. And then I'm going to divide by 2. I'm just going to leave my answer like that, negative 3 plus or minus 5i over 2. The reason being, there's nothing else I can really simplify. That fraction doesn't reduce, because they don't have a common factor. I can't combine, this is real, that's imaginary, you can't combine them, so you kind of have to keep them separate, but that's how you would write your final answer. So technically, could you use quadratic formula? Yeah. You just have to do a lot more work for the setup of that problem, and why do more work if you don't have to? So you guys are going to be getting an assessment, quiz test. I've given up on naming things. Next Tuesday, and we're going to make it do Thursday, so we're going to give you guys time. And I'm pretty sure for most of them it just says solve, so you can decide. Once again, don't make your life harder than it has to be. If something's set up like that, I highly suggest square roots. And you'll see ones like that in that packet, so just as a heads up. Any problems or questions? Yeah.
When it says solve, do we have to give the two answers for what x could be, or just the?
You could just give it like this, because the plus minus is representing the two. You don't need to separate it, unless you could actually combine them, but in that case we can't. So feel free to just leave it with the plus minus. Here you go. So there were two other ones that actually aren't even quadratic. We actually know how to simplify them and then solve, but I wanted to remind you of them. So let me show you these two. Just things that as I was going through this problem, I thought I think we should maybe do a refresher. One is, what happens if we need to solve a cubic? So one, quadratic formula is out. To use quadratic formula, you need to have a quadratic. You can only have something with x squared. Completing the square is out. Once again, you have to have it be something squared to complete the square. Square roots is out. You can't take the square root of something that has a cube. Factoring is going to be our friends for one that look different. Okay? Cubic, we're going to see one in a minute, that's quartic. So we know how to factor this. Some are difference of cubes. This is a difference of cubes. So we are going to factor this side. Factor, and once again, this is a difference of cubes. Let's see if we remember how to do it. So we did this back in the factoring chapter a while ago. That's why I'm giving you a refresher. So when I start, I have a binomial and I'm going to have a trinomial, just as a reminder. I take the cube root of this. So the cube root of 27 is 3, right? Because 3 times 3 times 3 is 27. The cube root of x cubed is just x. The cube root of 64 is 4. And then remember, SOAP, same, opposite, always positive. This is the same sign. So we start with that. And then basically our trinomial is based off that. So it's important you get that first one. Once again, we're just taking the cube root of everything. You keep the same sign. So then to write my trinomial, I take this first term and I square it. So 3x squared is 9x squared. So that was the same for the first side, opposite for the next side. For the middle term, I just multiply these two things together, so that's gonna give me 12, opposite, it would help if I actually wrote the opposite sign, is a plus. That would give me 12x. And then always positive, I squared that second term, which would just be 16. All right, so that's like bringing back, that's like going old school. We did that in like October, I think. So it's been a while. So I didn't want to just throw it at you and say, remember how to do it. But we need to solve this. So that's where the issue comes in. So solving this first one's easy. You just set it equal to 0. It's a quick 2-step equation. You find the first answer. X is going to be 4/3. Delightful. But this is why we kind of throw it in this chapter, because now when we solve that second one, that's a quadratic, and we go back to our methods that we can use. I'm just going to use, that's not factorable, so I'm just going to use quadratic formula. Once again, that always works, like good old handy dandy. If I need to solve and I don't really feel like doing another method, quadratic formula is going to be my friend. Okay, so I have A, B, C right in order. I'm just gonna throw them in. So that would be what, -12 plus or minus the square root of 12 squared minus 4 times 9 times 16. All right, let me just write it out. I'm gonna take a second. All over 2 times 9. So I took that quadratic, I set it equal to 0. I threw it in the quadratic formula using my coefficients. And now I grab my calc. I end up with x equals -12 plus or minus, and underneath my square root, I'll just throw that into my calculator. 12 squared minus 4 times 9. Oops, what am I doing here? 4 times 9, 16. Oh, I got -432. So no one said it was going to be a nice answer here for 18. So I think to myself, can I simplify that? Probably. So I'll take it off to the side. Remember, the negative is going to become an I. And then we have 432, and I'm going to try to break that down. What is 432 divisible by? 16. It's divisible by 144, I believe. Yeah, 144 times 3. I would have known. So that would simplify to 12 root 3. Okay, so you might have to do a little bit of, guessing and checking, just finding some factors that work. Oops, I need to leave myself some room. So Sherman, you nutbag. So we're going to leave that as 12I root 3. Remember, don't forget that I. Over 18. And then last but not least is we do need to reduce this. So remember, when we're reducing, you don't really look at the radical, you're just looking at the real parts. Those are all divisible by 6. So just find the highest common factor and divide it out. And I would end up with -2 plus or minus 2I root 3 over a 3. Woo! So know how for a quadratic you get 2 answers? For a cubic, you get 3 answers. For a quartic, you get 4. So we had 1 answer over here, and then this represents 2 answers to give us a total of 3. But usually when you're doing the difference or sum of cube ones, when you do get that quadratic part, once you factor it, quadratic formulas, where it's at. I mean, you could complete the square, but you have to divide everything by 9. It will get a little messy, so I always complete the square if it just is nice. So a reminder of difference or sum of cubes. So just as a heads up on that, something you might want to look over, at least write down. And the reason we kind of put it here is because once you factor it, then you have a quadratic. So just as a heads up. I'll leave that one up for a second though, that was a little longer. And I have one more to do with you. And you guys will have some time if you have questions. Oh no. If you have questions, we can answer them. If you see anything funky, we'll kind of just look through and see if there's any funky setups. You can always kind of just go through a setup if you need. Any probs on that one? Okay. All right, last one. So this one's a little different as well. So it's not necessarily starting with a quadratic, but maybe we'll end up with quadratics type deal. And what do we have? That was kind of nice with the setup for the minute. So we have this nice little equation. We want to solve it. And so what you get into the habit, you just like become a robot, right? You're like, all right, I'm just going to start solving. Be careful that you notice that that's to the fourth and it's not squared, right? So be careful. So you can't use quadratic formula. Quadratic formula is out if there isn't a squared as the highest thing. So quadratic formula is out. I can't complete the square. I can't use square roots. So once again, the ones that are a little different, you're going to factor. And most of them are things that we've seen in the past. You just need our reminders. So I'm going to factor this. Once again, I can start factoring because it is equal to 0. Just make sure it is before you start. So I'm going to factor this bad boy. So what do I get? That'll be 2x squared and just x squared, right? So remember, I need to split the x to the fourth up evenly. So we have x squared, x squared. When do we have 12? Is that 4 and 3? Because that would give me 8 and 3. And if I had negative 8 plus 3, that's negative 5. So we had to factor it. Now, when I factored it, it gave me 2 quadratics. And that's kind of what we're talking about. So it's really just getting into the point where we have quadratics that we can solve. So I'm going to solve both of those individually. The nice thing is I can use square roots because there's no x term in the middle. So I'm just going to split these up. I'm going to say 2x squared plus 3 equals 0. So I'll just start to solve this one. I'm going to subtract 3, just a good old 2-step equation. I'm going to divide by 2. Oops, it's x squared, right? So Sherman lost the squared there along the way. Here's where, it gets a little annoying, but we got to do it. We're going to take the square root of each side. I never leave my answer as the square root of a negative. Or excuse me, the square root of a fraction. That's actually what I care about. I don't want the negative either, though. So let me kind of do my work over here so you can see what I'm doing. So I'm going to write it as x equals. I'm going to split the fraction up. I'm going to have the square root of the top over the square root of the bottom. I'm going to rewrite that as I root 3, right? Because I don't want that negative underneath either, so that's going to mess me up. And one of our big rules was we never leave radicals in denominators, just like we never leave i's in denominators because they represent a radical. So the way we deal with it is we take whatever in the denominator and we multiply by that over itself. So technically we're multiplying by 1. It's just a fancy way to do it. And that would give me I root 6 over 2. Now, Mrs. Sherman was very bad, and I forgot my plus minus along the way, so don't forget about it. Plus minus, so it's plus minus I root 2. I root 6 over 2, excuse me. And those are my first 2 answers. So once again, the plus or minus represents 2. We started with a quartic, so we need 4 answers. So we have half of what we need. Once again, that was just a little annoying with just the radicals. Just be careful. Obviously, when I correct, I do get partial credit. So if you did some of that and you forgot like one little step, you've got most of the credit. So just show as much as you can. I need my other answer. So I need to go to this, x squared minus 4. This one will be a little less work. Because all I would have to do is add 4 to each side. And then that's just a nice when you take the square root of that, x equals plus or minus 2. So that one was a little bit easier to solve. So now we have our 4 answers. Positive 2, negative 2, positive I root 6 over 2, negative I root 6 over 2. So I'm gonna leave that up for a moment. But once again, just trying to do those little things that maybe like you're just going through, you're in a groove. You don't even realize there's a fourth there. That's something that's important. So it does make it a little bit different.
Can I go to the bathroom?
Yep, go ahead.
Thank you.
As far as some like other little things, like if you see something's factorable, go for it. But if you want to use quadratic formula, you're gonna get the same answer. So some of the things, we'll talk about how you know something is factorable later. So for now, if you can kind of visualize it, go for it. If not, use a different method. No big deal. Same thing with completing the square. If you notice it's like a nice setup, you can do it. If you want to do something else, that's fine. So when I did my answer key, I tried to do like a few of each. So there wasn't one, but once again, there's no correct way to do one problem. I'm just seeing if there's anything else that I thought was like kind of tricky. No. I tried to go through. Just pay attention. Yeah, there's a few that have x to the fourth, number 34 and number 36 do. There's a cubic at 41. There's a cubic at 44. We already, just to let you know, 46 is the same thing as 19, and we had already done 19. So if you want to make a note to yourself, 46 just write same as 19. It'll just save you. It was kind of that annoying one we did yesterday, so it'll save you from like starting it and then being like, that looks familiar. So 46 is the same as 19. You can just write same as 19 so you don't redo it. So you guys had kind of started yesterday. Was there any problems that you've run into so far that people have questions on or would like to go over? Once again, I'm like just kind of giving you that open-ended due date. So please make sure, one, I'm going to give you a little bit of time in class, but make sure you are using your time wisely and that you don't wait until Monday morning to start getting on that, because that will be due Monday at class time. Basically what we're going to do is I can go over this Monday during class. And then Tuesday you'll be getting that little assessment that basically I'll just give it to you Tuesday, say it's due Thursday. And then we're going to start some graphing stuff. So we're moving on after that. So you're still kind of at the same place. You can basically get up to number 46, which really 45 because you don't have to do 46. Tomorrow, there's just like one or two more like maybe little things I wanted to go over with you. We'll do them quick in the morning, and then I'm just going to say afternoon, just work on this. And then Thursday, we're going to go over discriminant, which is numbers like 47 to 58. And then Friday, we're going to go over some of the word problems. The word problems actually aren't bad because they're all set up for you. So you don't need to do anything fancy with setup. It always gives you the equation. You just need to know kind of what to plug in. So that's the deal for today.